Welcome back to our today's lesson. We continue from where we left. If you are joining us, just know that there is a video we did yesterday, and this is a continuation. So for you to catch up, go back there and update yourself. So we are looking at those areas where marks are got from, the areas that are tested, especially when you have tables to fill during titration. So just a recap of what we did in the previous video. The areas to be tested include the completion of tables, use of decimals, accuracy, principles of averaging, and in this one about the principles of averaging, I promised to provide examples of tables that are already filled and with the values, so that from the values provided we can know which ones to use when you are calculating the average and which ones to ignore. So with us we have two tables, and we will begin with the first one. In the first table, it is a titration table. That is why we have the burette readings, the final burette readings, the initial burette readings, and the volume of solution B used. So I used those letters, solution B, for the first table, and in the second table I have used solution A. They are just but examples. So these ones, the naming of the solution used will depend on what has been provided in the procedure. So do not just take like it can always be solution B or solution A. It can even be solution K, solution J, depending on how the solution to be titrated is labeled in the procedure. So in our first table, we have the burette readings, the trial, the first, the second, and the third. Burette readings, we have the trial, the first, the second, and the third. So let us check the values down here. In our first one, we have 16.6. The first is 16.0. The second is 16.0. And the third is 16.1. In that point that we talked about in the previous video about the principles of averaging, it was explaining to us that we only take those values that have a difference from one value to the next, a difference of either plus or minus 0.1 or plus or minus 0.2. So that is the difference that should be there, plus or minus 0.1 or plus or minus 0.2. That is to mean from the biggest value to the smallest, and if there are other values in between, from one value to the next, you are supposed to do subtraction. And if the difference that you get after you did the subtraction, if the difference that you get from one value to the next is plus or minus 0.1, that is the smallest difference that should be you should get. If you get a plus or minus 0.1, that means that the values that you have are very accurate. If the difference is bigger than 0.1, then the biggest you should have is a plus or minus 0.2. If the difference is bigger than 0.2, then that is to mean that that value should be discarded, or you should not use it. In our case, from 16.6 to 16.0, the difference is plus or minus 0.6. From 16.0 to 16.0, the difference is just a 0. So it is even more accurate than even a 0.1 difference. The same with this one. The difference from 16.0 to 16.1 is a plus or minus 0.1. So this one has the biggest difference, that is outside the bracket of the differences that are needed. So when you are calculating the average, we ignore this one. We ignore that one. So in the averaging, we can only, in this case, use 16.0 plus 16.0 plus 16.1. And now that we have chosen to use 3 values, that then means that once you write 16.0 plus 16.0 plus 16.1, you should divide by 3 because you have used 3 values. If only 2 values were chosen, if only 2 values met the difference that is required, then you could only take the 2 values, but this time round you divide by 2. So if you use 3 values, you divide by 3. If you use 2 values, you divide by 2. If only one value was to be taken, if only one value was to be taken, because there comes a time when you have done the titration, you get different values. All of them are different from one to the other, and all of them have got a bigger difference from one value to the other. So you get confused, and it is during K.C.S.E and time is gone. So you only take that value that according to you was very accurate in the manner that you did the titration. You take that value that according to you was the most accurate, that according to you had minimal errors, because at times time is so much gone and you cannot just keep on repeating the titration, or maybe the chemicals that you have been provided with are not there. You have used all of it and there is no much to be given, and time also is gone. So you just take that value that according to you you did when you were very accurate. So we go to the second table. In the second table, we have burette readings, final burette readings, initial burette readings, and the volume of solution A used. Then you have the trial, the first, the second, and the third. So in this case, again, in the trial, we have the biggest value. In the trial, we have the biggest value, 25.0. Then we have 20.0, then 20.1, then 20.2. From the first value to the second, the difference is 0.5. From the second to the third, from the first to the second, the difference is 0.1. The second and the third, the difference is again 0.1. If you again try the trial with the second, the difference is 0.4. If you try the first one with the second, the difference is with the third, the difference is 0.2. So, not 2 but 3, sorry. So, if you consider such values, then it then means that again you ignore the first one. You ignore the first one. So you take the first, the second, and the third value. So in the averaging, you take 20.0 plus 20.1 plus 20.2. And again, because there are three values, you divide by 3. So in our next table, I will be showing you what you are supposed to do in case during K.C.S.E. you have done your titration and for some reason, maybe out of anxiety, you spill some chemical, or out of anxiety, some of the chemicals are contaminated. As you do your other experiments, you, for some reason, by mistake, you contaminate the chemicals. Yani, something just happens that will make you not have enough chemical to use. And you go asking for more, and you're told there is no much that you can be given. All, according to you, the time that is remaining is not enough. You are not able to do then the titration depending on the number of times that you have been told to do it. So what are you supposed to do? That is what we will do next. So next, we are going to look at a few things that can happen to the student that will necessitate him or her to save the situation. You see, even the student is a human being, and human beings can always do mistakes. So maybe the student has spilled his or her chemicals. Or the student wants to repeat the titration experiment, but no chemicals have remained in the school laboratory. Maybe because the student has contaminated his or her own chemicals, or maybe the student still feels that he or she did a mistake during the number of times he had done the experiment, and still feels that there is need to repeat the experiment. But he or she is told no chemicals are remaining in the school laboratory. Because the student need to know that most of the time, the chemicals that are provided by NEC is just enough for the number of students that are in that school. And most of the time, you'll have the students wanting to have more of the chemical, but nothing has remained. Except in that few instances when the chemicals that were needed during K.C.S.E were also in the school store. Those are the only situations when more chemicals can be available. But if all the chemicals were provided by NEC, there are chances that the chemicals have not remained. Number 3, when only a few minutes are remaining and the students still need a few more minutes to do the calculations thereafter. Because the thing is, it's not only the table that will be needed during a titration experiment. There are also calculations that come after that. But this student has an empty table, or has only filled one part of the table, and still has other columns to fill. So what is the student supposed to do? So first of all, if the question requires you to draw your own table, maybe the table is not drawn for you, you are supposed to know that in the arrangement of the table, the first one will be for the burette readings, and you need to write the units, the centimeters cubed, because those are the units in a burette. Then we have the final burette readings coming on top, and then followed by initial burette readings, and for both you write the units. Then lastly, down there we have the volume of the solution to be used, and it will be very necessary for you to indicate the the name of that solution. And in the name, I mean the letter that has been used to name that chemical, maybe solution A or solution B, solution K, whatever. So that one, you don't just cram, you read it from the procedure that has been given. So you have an empty table, or it is not yet complete, and for those reasons that we have just said up there, you still need to think of how to save the situation. So this is what you're supposed to do. You just think of values from your mind. You trust your mind now. You trust your mind. And if you are lucky to have done the first, the better. If the electrochemical remaining, if time is there, if the electrochemical that you have remained with after maybe it was spilled, and it is enough to at least do the first, well and good. That is even a better situation. But if you have an empty table, this is what you should do. So you are supposed to go to the initial burette reading, and you indicate that you are starting from a 0.0, I mean a 00.0, because remember, you still need to take care of the decimals. And in our previous video, we said that it is recommended that you only use 1 decimal place. And I told you that that is what I would recommend for you, because it is what can be accurate for you when you are doing calculations. So once you indicate that the initial burette reading is 0.0, then you think of a value. Like let's say 25.0. So you write it up there. Still taking care of the decimals. Then downwards we subtract. So 25.0 minus 00.0, you get 25.0. So you already done with the first. As you go to the second, you take this one, the first one that you had, then you indicate it here. You indicate it down there, because this was the initial, this was the initial, this was the final. The final should be the initial for the second. And now that the whole burette is from 0 to 50, you can only say that this one went down to 50. Then you subtract. Then you get 25.5. I mean 0.0. I already said that the final should be the initial for the third. But in this case, you cannot write 50 here. You cannot write 50.0. Reason, when you indicated that this one has gone up to 50, it means that all the chemical in the burette has been used. So if you indicate here that this is the initial, it will be an unrealistic value. Unrealistic value. In our previous video, we talked of that when you are filling the table, you should avoid unrealistic values. So there is no way that an initial reading can be from 50, but a final reading can be 50. So what do you do with this one? What you are supposed to do with that one is you say that now the initial go back to 0. It go back to 0, and then you say You do not want maybe all of them to look the same, so you say maybe this one went up to 26, and then the difference is 26.0. The difference is 26.0. So you have made a table to save the situation. You have just made a table to save the situation. So when you'll be calculating the average, remember, as I have just explained, as we began this video, I said you are supposed to check on the values. So when you check the values, for you to know which ones to use when you are calculating the average, you begin by looking at the difference between the first and the second, and the difference is 0. And if the difference is 0, it means you can pick on them, because the difference is even smaller than the plus or minus 0.1. From 25.0 to 26.0, the difference is 1.0. And if the difference is 1.0, that difference is so big, because remember, the smallest difference that you should have is plus or minus 0.1, and the biggest difference is plus or minus 0.2. But now between 25.0 and 26.0, the difference is one whole number, so the difference is so big, so you ignore this one. So you pick on 25.0 and 25.0. So when you be calculating the average, you pick on 25.0 plus 25.0, then you divide by 2, because this time round you have used two values. You have just used two values. If you still want to save the third, there is a way you can still save the third value to make it remain, so the third. So you can say you still want to use 3 of them, so you say 0.0. Instead of the 26 that we had, you say this one has gone up to 25.0. There is no harm in having all of them look the same. Or you can say here, but other than 25.0, you say 25.1. Then down here you say it will be 25.1. The values will still be okay. And at that time, you can use the 3 of them, then divide by 3. Divide by 3, because there will be 3 values to use. So let me say this, which is again another very important point. You can be asking yourself, now that I have shown you on how to cook a table, because you are getting the values from your mind, is that bad? Let me say this. Sometimes it calls for wisdom. It calls for wisdom to save a situation, because you still need a values to use when you are doing your calculations thereafter. So it is not a matter of if you cooked the values or if you have done the experiment. No one will be there to know whether you did it or whether you didn't do it. But if you still have the chemicals, you are supposed to at least do one. And again, if time is allowing you to do the first, at least the first. So this should be remembered, that the values you get in your table are the same values that you should use when you are doing the calculations. How are the values used during the calculations? Once you do the average, the value that you get will be the volume of the solution that you had indicated in your table. So anytime you are doing a calculation involving that solution, like in our case, I gave an example of solution K, that value that you get for the average is the volume that will always be for solution K. So the values that you get in your table are the same values that you should use in your calculations. Whether the values were correct according to what the teacher got, or even if they were not correct. There is a secret that you should know as a student, that when you are doing your titration experiment and even other experiments that need a table to be filled, when you are sitting for your K.C.S.E exam, your own chemistry teacher is also sitting for that exam in this way, that the teacher will have to do that titration or that enthalpy change or whatever other experiment that needs a table. The teacher will have to do the experiment him or herself and fill his or her own table. And the paper that is provided for the teacher, after he or she has done the experiment, that paper is put together with the students' papers. So those values that your teacher gets are the marking scheme for that school. So it should not worry you if you cooked the values and maybe your values do not look the same as that ones of the teacher. If they are not the same, you will only miss a mark for the accuracy. But if you cooked the table and you have the correct decimal places, like now in our table we have one decimal place throughout. Every place it is one decimal place, so you get a mark for the decimal place. You have not indicated any unrealistic value, because all the values that you have indicated are values that can be read from a burette. So again, you get that mark for where realistic values have been used. You get that mark. So again, you have completed the table. So remember, where you get marks from are from these areas. 1, completion of the table. The table is already complete. There is nowhere you have used unrealistic values. The decimal place is okay. Then when you're doing the averaging, you used the values that are correct, that have a difference or plus or minus 0.1 or plus or minus 0.2. So the only mark that you will lose if your value is far much away from the teacher's value is only the mark for accuracy. But if you are lucky, and let's say that after you have these values, maybe your teacher got an average of, let's say, 25.1. That is the value that your teacher got when he or she was filling the table. There was a place where your teacher got 25.1, and in your table you have 25.0. It then means you will also get the mark for the accuracy, because what is checked is if in your table you have any value, even if it is one of them, that is having a difference of 0.1 or a difference of 0.2 from yours to the teacher. From yours, if 0.1 is added, it goes to the teacher. If from yours to the teacher, if a minus is done, the same difference, 0.1 or 0.2, you still get the mark for average. So in other words, it is very necessary that you know as a student, just like a police who is in a battlefield and has to do something when injured, you should also behave the same way and make sure that you have saved the situation. because there'll be no one to understand your situation. If you come out of the exam room, the experiment room, the practical room, and you go telling people, oh, I spilled my chemical, so I was not able to fill the table, or I contaminated my chemicals, so and I asked for more, no one was there to give me more to complete the titration. I spent my time in other experiments, and when I reached the titration experiment, there was no time remaining, so I left the table not filled. I didn't do the calculations. There'll be no one to understand you, so you have to save the situation. So I am a teacher, and though I'm not supposed to teach you how to cook various, I need to also assist you to save the situation. Because even after you have cooked, and then you use those values that you have got in the correct way during the calculation, you still get marks. So the other question that I need to answer here is, what if the values that you get and the teacher's value in your school, those two values are having a big difference, so you have already lost the mark for accuracy? What will happen if you have you still use your values that were not accurate? You still get marks in each and every calculation. The only mark that you are likely to lose is the final mark, because some of the titration calculations, some of them, not all of them, some, they will be asking you at the end of it to calculate the RAM of a certain element. So if it is such a calculation that requires you to calculate the RAM of a certain element that was in a certain formula that was unknown, then it means that if from your table you didn't have the accurate values, it means that when you go on using those values, at the end of it all, you'll not get the accurate RAM of that element. So you'll only lose that final mark for the RAM, for the RFM, because they will not be accurate. But if in every step you still use your inaccurate values correctly, the way they are supposed to do, if it is in a calculation of morality, you have used the correct way of calculating morality with their own values, you still get marks. So that is it. I will be giving you more hints on how to go about the titration practicals, as in any way, all we have to save the situation, and we have to make sure that all said and done, we have reached our goal. And what is our goal? To pass in our exam and to get the best grade that we have ever dreamt about. So we shall meet in our next lesson, and I only have one request: please subscribe if you have not. Please tell a friend to tell a friend that we have this channel, and so that many students can be assisted in their revision. NB, this being a practical exam, the practical marks can always assist you to get a better mark. The theory marks will still count, but if you're able to pass in the practical, your grade will be a better one. So I'm not saying that you're not supposed to revise on the theory part of it, paper 1 and 2. It will still be necessary for you to be serious on the same, but also take time and know how to do the practical. It will save your grade. It will really save your grade. So I'm wishing you the best. Please subscribe, please share, please like, please comment. If you have any question, any area that you need us to do, just comment. I wish you the best. Have a good time.